Today's lesson we're going to be adding and subtracting polynomials. So last time we talked about classifying and naming polynomials, and today we're just going to keep going with that topic. Now I want you to note up at the top here that when you're adding or subtracting two different polynomials, you got to make sure that you put both polynomials in standard form. Let me also mention that your answer should always be in standard form. And remember, standard form is just when you write the terms from biggest exponent to smallest exponent. Okay, so kind of keep that in mind. Standard form matters, essentially, is what I'm saying. Now, on the front, we're going to add polynomials together. This is not that bad. It's just really like combining like terms. There's two approaches to being able to do this. I'm going to show you both ways on example 1 here, and then you're just going to pick whichever method you like better and stick with that from here on out. So if you use the vertical method for these, here's what you have to do. And I'm going to say it before I even start either method. If this is an addition problem and you're just adding two polynomials, in this case these are both trinomials, 3 here, 3 here, the parentheses do not matter if it's an addition problem. Okay, so I'm going to write that right from the get-go. Ignore the parentheses. If you're doing the vertical method, the advantage to this is there's less mistakes. So people usually get it right more often than not if they use a vertical method. I will tell you this method is not very popular. I myself do not use the vertical method. I use the horizontal method. And the reason I think it's not popular is because it takes longer. But realize there's less mistakes if you are to choose this method. So the reason it takes longer is because you have to rewrite the two polynomials. You have to line everything up and write the two polynomials on top of each other. So here's what I would do. I would take 4x squared plus 6x plus 7. I'd write the first polynomial first. And then underneath it, I would put the second polynomial. So you always have to rewrite it if you're using the vertical method. Now, this one's pretty easy to write because they both have x squareds. They both have x's. They both had a constant. So they're both trinomials. So this is the easiest example of the vertical method. But you need to know, and so some tips here for this method, you have to line up like exponents. So the x squareds need lined up. The x's need lined up. You got to make sure you do that part, otherwise you'll combine things you cannot combine. But once it is all lined up, you just add or subtract the coefficients and realize that the exponent never changes. So here's what I'm talking about. I need to combine the x squareds. So I just add the coefficients in front. 4 plus 2, that would be 6x squared. Notice that I did not say 2 plus 2 and say x to the 4th. You don't change the exponent, you're just counting how many x squareds there are. Okay, then I would do 6 plus negative 9, that's negative 3x's. And then 7 plus 1 is 8. So you're essentially just combining like terms after that. And we kind of did a little bit of that last lesson. So hopefully this isn't too terrible. So advantages, less mistakes. Disadvantage, it takes more time. So here's the horizontal method. The advantage here is it's much quicker, which, yay, I like that. And that's why I picked this method. All right, the tips on this one, you don't have to rewrite it. That's why it's faster. You just have to identify and mark like terms. From there, the last two little tips are the same. You just add or subtract the coefficients. Keep in mind that the exponents never change. You're not putting the x squareds together and saying x to the 4th. You're just counting how many x squareds there are. For the sake of this problem, I do have to rewrite it, but in the future, I don't have to, which is nice. I am going to ignore the parentheses, so I'm just going to copy this exact problem without the parentheses. And I just have to mark like terms. So I do that with different shapes. So the x squareds, maybe I'll circle both of those. This is 4x squared, this is positive 2. Keep the sign in front of a term with it. So I just need to put these two guys together. Well, 4x squared plus 2x squared is 6x squared. And then maybe cross those off because I've used those. I've combined those. Then I'm going to look for the x's. So maybe I'll put like boxes around those. There's 6 there. Plus negative 9. I always think I'm adding. It's 6x plus negative 9x. If you need a calculator, use it. That's negative 3. So just put minus 3x. And then the constants, maybe I'll triangle those. 7 plus 1, obviously just 8. You get the same answer regardless of the method. It's just a different way to approach the problem and look at it. So I'm going to do the horizontal method for this second one here. I know that it's an addition problem, so basically I'm going to just ignore the parentheses. I like to cross them off. They do not matter. All you're trying to do is combine like terms. So look for like terms. Let's see. I see x cubed terms. So let's box those. There's 9x cubed and negative 3x cubed. I always think about adding. 9 plus negative 3 is 6x cubed. Okay, I like to cross those off so I remember I used them. Next down the line, if I'm thinking standard form, which I should, would be x squared. That would be the next biggest exponent. So right here, I have 5x squared, and there's no other terms that are x squared, so that just stays 5x squared. Then would come the x's, and there's just 13, so you can't combine it with anything. But then I've got constants. I've got negative 7 plus 4, which is negative 3. So that would be my sum. All right, that's not too bad. The signs can mess us up, but other than that, people usually do really well with that stuff. Now, when you're subtracting or finding the difference, it's kind of a different story. Way more places to make mistakes. So here's the difference on these. The parentheses actually do matter if it's subtraction. And I'm going to give you a little helpful trick. The helpful trick here is that you just flip each sign in the second group of parentheses, and you only flip it in the second group, and then the problem just becomes an addition problem. Okay, so here's what they're telling me to do. They're saying the second group, I just changed the sign here. So I make this one negative, make this one positive, make this one negative. Flip the signs. The reason that that works is because the minus sign right here in front of that set of parentheses is just like a negative 1. Or the minus sign itself is like a negative sign. And I know that would be a negative 1 sitting right there. So essentially, you guys, all you're doing is like just distributing negative 1 to all 3 of those terms. And I know that if I multiply something by negative 1, that just flips the sign of that term. Okay, so again, for the sake of this problem, actually I'm not going to rewrite it. I'm just going to use it up here. So here's what I would do, and I would rewrite it if I were you on this one, but basically the first set of parentheses, that polynomial, the parentheses don't matter on it now. So just copy that down without the parentheses. Go ahead and distribute the negative 1 to the second set, and then write what you get without parentheses. So negative 1 times 1x cubed would be negative 1x cubed. And this would become a positive 8x squared. And that would become a negative 11. Okay, so after I've distributed the 1 or just changed the signs of the second group, I'm going to rewrite it without parentheses. And now I just do exactly what I just did. Now it's an addition problem. So you're just combining like terms. So x cubed is the biggest exponent. So let's combine those first. There's 2. And I always add. 2 plus negative 1 is 1x cubed. X squared. So there's 5 plus 8. So that's 13x squared. The x's, there's only negative 3. And there's only one constant, it's negative 11. Okay, I want you guys to try example 4, and here's how you can kind of make the horizontal method, like, make it quicker for you. You don't need the parentheses for the first group, doesn't matter. You just change the sign of the second group, and you're changing this then to an addition problem. So you could just change that to plus, and then just change the sign, so that'd be -3 now, that'd be +8, and that would be a -2. So if you can read it from there, go ahead and just start combining like terms. If you need to rewrite it, 7m squared minus 5 minus 3m squared plus 8m minus 2, go for it. But try that one and see what you get. If you want to do the vertical method, go for it, but I stick with the horizontal. If you really feel like the vertical method might help you, I'd be happy to do a lot more examples in class with you to help you practice that. All right, I'm going to end with a geometry problem. Yay, don't we love these? Now, they give me a shape. This is a quadrilateral. It's got 4 sides. And they say the perimeter of the figure is 25c plus 9, which doesn't mean a whole lot to me, but that's okay. I want to write an expression to represent the last side. Now, there's a problem here. They should have given me this side. So I don't know if it just got left off of the copy, but that would be there, right? 4c right there. This would be the problem. They'd give you the perimeter. You'd have to find this side right here. Okay, you have to remember what perimeter means. And if you forget, perimeter is when you add up all the sides. That's what it should equal. So I'm going to write an equation that looks like that. I know if I add all these, so 6c plus 3c minus 4 plus 4c plus the question mark. We'll get that guy in a different color here. If I add up all 4 sides, question mark included, I should get 25c plus 9. I basically just need to figure out, well, what does the question mark equal? So you're going to do this like you would any other algebra problem. So what I'm going to do is I'm going to look on either side and see if I can combine things. So I see on the left-hand side that I can put a bunch of c's together. So I see I've got 6c plus 3c plus 4c. So that's 13 c's minus the 4 plus the question mark equals 25c plus 9. Now, basically, I need to get the question mark by itself. So I'm going to move the c's over next by subtracting it. And I'm going to subtract it where I have like terms. So underneath the 25c, the colors here are getting me. So 25 minus 13, that'd be 12c plus 9. Then if I move the 4 over, I'm going to have that fourth side, that question mark by itself. So really the question mark, the fourth side, just equals 12c plus 13. Yay, geometry. Get excited for next year.